And get started. Good morning, everyone. I am Leah Smiley, president of the Institute for Diversity Certification, and I am so excited to join you today to talk about our latest certification program, AI, the Automated and Machine um, Bias Prevention Learning Management Program. So we're going to talk more, or the AMBP program. We're going to talk more about the program and what it entails, and then we will answer your questions. But first, I just want to start off with a short video. This will kind of give you an idea about some of the things that we cover and how we approach the program. For those of you who may not be familiar, I just want to show a brief video on machine learning. And usually when we do the program, we will engage in a variety of different videos and all sorts of discussions about case studies and other tools that are available. But this video will provide us with more instruction in terms of where we're going to go on our presentation.
We know humans learn from their past experiences, and machines follow instructions given by humans. But what if humans can train the machines to learn from their past data and do what humans can do and much faster? Well, that's called machine learning. But it's a lot more than just learning. It's also about understanding and reasoning. So today, we will learn about the basics of machine learning. So that's Paul. He loves listening to new songs. He either likes them or dislikes them. Paul decides this on the basis of the song's tempo, genre, intensity, and the gender of voice. For simplicity, let's just use tempo and intensity for now. So here, tempo is on the x-axis, ranging from relaxed to fast, whereas intensity is on the y-axis, ranging from light to soaring. We see that Paul likes the song with fast tempo and soaring intensity, while he dislikes the song with relaxed tempo and light intensity. So now we know Paul's choices. Let's say Paul listens to a new song. Let's name it as Song A. Song A has fast tempo and a soaring intensity, so it lies somewhere here. Looking at the data, can you guess whether Paul will like the song or not? Correct. So Paul likes this song. By looking at Paul's past choices, we were able to classify the unknown song very easily, right? Let's say now Paul listens to a new song. Let's label it as Song B. So Song B lies somewhere here with medium tempo and medium intensity. Neither relaxed nor fast, neither light nor soaring. Now can you guess whether Paul likes it or not? Not able to guess whether Paul will like it or dislike it? Are the choices unclear? Correct. We could easily classify Song A. But when the choice became complicated, as in the case of Song B, yes, and that's where machine learning comes in. Let's see how. In the same example, for Song B, if we draw a circle around the Song B, we see that there are 4 votes for like, whereas 1 vote for dislike. If we go for the majority votes, we can say that Paul will definitely like the song. That's all. This was a basic machine learning algorithm also. It's called k-nearest neighbors. So this is just a small example in one of the many machine learning algorithms. Quite easy, right? Believe me, it is. But what happens when the choices become complicated, as in the case of Song B? That's when machine learning comes in. It learns the data, builds the prediction model, and when the new data point comes in, it can easily predict for it. More the data, better the model, higher will be the accuracy. There are many ways in which the machine learns. It could be either supervised learning, unsupervised learning, or reinforcement learning. Let's first quickly understand supervised learning. Suppose your friend gives you 1 million coins of 3 different currencies, say 1 rupee, 1 euro and 1 dirham. Each coin has different weights. For example, a coin of 1 rupee weighs 3 grams, 1 euro weighs 7 grams and 1 dirham weighs 4 grams. Your model will predict the currency of the coin. Here, your weight becomes the feature of coins, while currency becomes their label. When you feed this data to the machine learning model, it learns which feature is associated with which label. For example, it will learn that if a coin is of 3 grams, it will be a 1 rupee coin. Let's give a new coin to the machine. On the basis of the weight of the new coin, your model will predict the currency. Hence, supervised learning uses labeled data to train the model. Here the machine knew the features of the object and also the labels associated with those features. On this note, let's move to unsupervised learning and see the difference. Suppose you have cricket dataset of various players with their respective scores and the wickets taken. When we feed this dataset to the machine identifies the pattern of player performance. So it plots this data with the respective wickets on the x-axis while runs on the y-axis. While looking at the data, you will clearly see that there are two clusters. The one cluster are the players who scored high runs and took less wickets, while the other cluster is of the players who scored less runs but took many wickets. So here we interpret these two clusters as batsmen and bowlers. The important point to note here is that there were no labels of batsmen and bowlers. Hence, the learning with unlabeled data is unsupervised learning. So we saw supervised learning where the data was labeled and the unsupervised learning where the data was unlabeled. And then there is reinforcement learning, which is reward-based learning, or we can say that it works on the principle of feedback. Here, let's say you provide the system with an image of a dog and ask it to identify it. The system identifies it as a cat. So you give a negative feedback to the machine saying that it's a dog's image. The machine will learn from the feedback, and finally if it comes across any other image of a dog, it will be able to classify it correctly. That is reinforcement learning. To generalize machine learning model, let's see a flowchart. Input is given to a machine learning model, which then gives the output according to the algorithm applied. If it's right, we take the output as our final result. Else, we provide feedback to the training model and ask it to predict until it learns. I hope you've understood supervised and unsupervised learning. So let's have a quick quiz. You have to determine whether the given scenarios uses supervised or unsupervised learning. Simple, right? Scenario 1. Facebook recognizes your friend in a picture from an album of tagged photographs. Scenario 2. Netflix recommends new movies based on someone's past movie choices. Scenario 3. Analyzing bank data for suspicious transactions and flagging the fraud transactions. Think wisely and comment below your answers. Moving on, don't you sometimes wonder how is machine learning possible in today's era? Well, that's because today we have humongous data available. Everybody is online, either making a transaction or just surfing the internet, and that's generating a huge amount of data every minute. And that data, my friend, is the key to analysis. Also, the memory handling capabilities of computers have largely increased, which helps them to process such a huge amount of data at hand without any delay. And yes, computers now have great computational powers. So there are a lot of applications of machine learning out there. To name a few, machine learning is used in healthcare where diagnostics are predicted for doctors' review. The sentiment analysis that the tech giants are doing on social media is another interesting application of machine learning. Fraud detection in the finance sector and also to predict customer churn in the e-commerce sector. While booking a cab, you must have encountered surge pricing often, where it says the fare of your trip has been updated. Continue booking? Yes, please, I'm getting late for office. Well, that's an interesting machine learning model which is used by global taxi giant Uber and others, where they have differential pricing in real time based on demand, the number of cars available, bad weather, rush hour, etc. So they use the surge pricing model to ensure that those who need a cab can get one. Also, it uses predictive modeling to predict where the demand will be high, with the goal that drivers can take care of the demand and surge pricing can be minimized. Great! Hey Siri, can you remind me to book a cab at 6 p.m. today?
Okay, I'll remind you.
Thanks.
No problem.
Comment below some interesting everyday examples around you where machines are learning and doing amazing jobs. So that's all for machine learning basics today from my side. Keep watching this space for more interesting videos. Until then, happy learning.
Okay, so I wanted you all to see that video so that way you can kind of get an idea of where we are and not start from a different point than what we're going to talk about today. This particular topic is very important because we're going to look at how process oversights can result in bias. And I'm going to talk about what the AMBP-L program does and how it can help your organization to ensure that it does not experience risk unnecessarily or other challenges. This program is, again, relatively new, but I'm going to give you an overview of what to expect when you are in this program, as well as talk about what it actually consists of. Now, it's not going to be a magical program where we tell you, okay, what to do, and then everything magically happens. This program is really going to help you to think different, and it will require you to learn. It'll challenge you to grow. It will also allow you to be equipped to have the right language to use when you're having conversations with others and talking about why there's a need to do things differently. So, this program is a unique blend between AI and ML, or artificial intelligence and machine learning, and diversity, equity, inclusion, and accessibility. So, you're going to learn from both perspectives. On the AI ML side, we had Nagesh, who's a certified data scientist specializing in cognitive enterprise through AI and ML. He's worked on several large scale projects as well as developed custom algorithms. And he utilized a team of multinational subject matter experts. On our team, um, I actually led the process to add the DEI components in. So you will learn from the AI, ML side, as well as the DEI side. So it'll be a complete blend, which will equip you not only with the language to use on the DEI side in order to ensure that there is trust from a human-centered perspective, but it'll also equip you with the language on the AI ML side, which will engender trust and communication on the technology side. A lot of times when people think about technology, they get excited about all the capabilities. It's going to save time, it'll save money, resources. It will allow us to be more efficient. It will allow us to um, operate in a way that will be cutting edge and that will even gain us uh, more credibility, and it'll improve our brand. It'll do all these wonderful things. We don't think about the risk that are involved with technology that is flawed. We don't think about the challenges that could come about from having a problem that impacts maybe one or two people, and now it's scaled to impact thousands or millions of people. We don't think about some of the outcomes that could happen that could literally change someone's life. We're going to explore those things in the AMBP-L program and really make it so that you can balance the perspective of the technology along with the impact on real life people. And this certification demonstrates that leaders are employing a holistic process to identify, prevent, correct, and or remove bias from innovative technologies. Yes, the innovative technologies can do wonderful things, but we also have to balance that with the risk and the ethics of this work. So there are a lot of challenges that we'll go over and talk about in the program. Um, a lot of times, what will happen is organizations will inadvertently have systems that use proxies for protected categories. So, you know that race and gender and sexual orientation, gender identity, age, all those different areas are protected categories by law, right? But sometimes we will have technologies that use what we call a substitute for helping the system to identify what those protected categories are. And those Proxies could include a zip code where someone went to school, perhaps their name, social economic status, a lot of different areas that will give clues to the system to help identify a person and ultimately allow the system to analyze data, compute, predict, recommend, or make decisions based on one's protected categories. Now, in many cases, this will mirror current discriminatory practices. In many instances, it can be looked at as garbage in, garbage out, right? So if you put garbage in, meaning that your current process is flawed or discriminatory, then you're going to get garbage out, right? So when we have a process that is already flawed and we're going through the process of saying, okay, let's identify what are functional requirements and our non-functional requirements, or what are the absolute necessities that we need for the system. And we're saying, okay, well, here's how we do things currently. If that process is flawed, yes, you're going to get flawed results when it comes to your technology. There's also the challenge of using protected attributes to serve as predictive variables to determine outcomes. What does that mean, Leah? You just seem like you said a lot of different things. Well, this is where perhaps you look at a protected category and determine whether or not someone is more likely to do something. Because again, we're using the system to predict, recommend, make decisions, uh, compute, right? And let's say that someone is a woman and the machine learns that women are likely to perhaps have a baby and go out of work and be a homemaker. So therefore, the woman should not be granted with a large amount of credit because she is more likely to not have the income to pay it back. You could also have protected attributes being used to make healthcare decisions. We may have, for instance, someone who is a doctor, for instance, that goes through perhaps what we'll call a checklist, right? So this checklist will determine whether or not the individual gets additional tests. It will determine whether or not the doctor asks more questions about what could possibly be ailing the person. There could be a variety of different things that will determine whether or not the insurance company will even cover the procedure, right? The diagnostic procedure, or even a predicted path for health and wellness, right? So we may have a lot of attributes, and let's say the person goes through a list of questions, and the doctor or the healthcare provider notes that the person is perhaps Black or LGBTQ, and as a result, it will determine whether or not the individual gets additional care. And sometimes you may go to the doctor and you'll say, you know what, I've had this problem for, 6 months, and I've come to the doctor 5 times. And the doctor keeps saying, oh, well, there's nothing wrong. There's nothing else we can do. We don't need any additional tests. Well, usually that happens because they're using a technology that is algorithm based that determines whether or not you should be referred for additional care, or whether or not you should have additional tests done, right? And when we look at the fact that people are dying, and the number of people that are dying, no one is bothering to question whether or not these outcomes are actually accurate, right? No one's looking at the data and saying, "Hey, what happened to this patient?" Right? The same thing can happen in education. During the over the last couple of years, we have had this huge debate about affirmative action, right? And we talked about how race was used in respect to decision making about college admissions. But we didn't talk about how the algorithms were playing a role in making decisions, right? We didn't talk about whether or not any algorithms perhaps use proxies to determine whether or not someone is more likely to complete their degree or whether or not someone is more likely to be successful at the university. And certainly these are the kind of issues when they're left out, they cause people not to trust either the system, the process, or the organization that is utilizing this system or process. Another challenge is loading incomplete training data, and we go into extensive um, background into what training data is, how it's used, and why it's so important to this process. And then finally, lacking guardrails. And we can see this when we're talking about um, using automated images and the fact that you can now go on to X and you can play around with their Grok 2.0 system, and you can develop deep fakes. You can create all sorts of different images. We take a look at all those different things too. We look at a lot of different systems and some of the challenges that they face, but certainly um, you can use um, technology to develop artwork, and that artwork can be biased, right? It can be misogynistic. And certainly because you don't know who produced it, you could have someone in your organization that inadvertently uses an image that is flawed, that was created by flawed technology, and ultimately it can produce a lawsuit. There are a lot of things. So from the very basic level, we say, okay, how can we prevent all these different things? On the basic level, we can say, okay, well, you know what? If we had developers, system designers, we had data scientists that knew more about DEI, we would be in a better position. We wouldn't have all these different issues if we had people that knew more about perhaps race, age, ethnicity, physical ability, mental abilities, and different disabilities, and sexual orientation, and citizenship, and education, geographic location, and how all these different areas can be proxies on the second level. Um, but certainly, one of the things that we don't talk about is how bias can manifest in other ways outside of those. So, that identity group bias right here is one type of bias, but there are a variety of different types of bias that can crop up during the course of your training the machine, or during the course of your developer or designer or your scientist training the machine. So, what happens in that process is you're not adequately prepared for some of the challenges that you will face. Now, usually, for those of you who have gone through the CDE program, the Certified Diversity Executive Program, you know that we have we've done work on clustering models. And in this program, this AMBP-L program, you will continue to learn more about clustering models and what those clustering models actually mean for us to detect anomalies. Why is this important, Leah? I'm so glad you asked. These anomalies actually can help us predict system failures, right? They can help us to identify flaws. But again, when we have process oversights, it results in these biases, these system biases that allow us to have these flawed outcomes. Right. And a lot of people don't know what to expect or even what to look for. We get so excited, woo, about the technology. Oh, this technology is going to do such great things. It's going to save us money. It's going to do all these different things. Oh, yes, it's awesome. Right. But we don't ask enough questions and we don't know what to ask. So it's kind of like a black box, right? Where we have this black box. We don't know what's in the box. We just know it's a black box, right? We just know that this box will provide us with some answers, but we don't really know what type of answers we should be looking for. And this is where there are challenges that come up, right? So again, if the system is being used to compute, predict, recommend, make decisions, analyze data, uh, it can impact not only our brand, where you think about Boeing and how Boeing actually had the system challenges where they had this new technology and they saw that there were, after the first accident, they said, oh, okay, you know what? After we had this first accident, the reason why the first 737 MAX jet crashed is because of, the cultural challenge, right? They looked at it as an outlier. They didn't really look at it and say, let's do some more analysis. Let's ask some more questions. Let's make it so that we do a little bit more, right? But that's usually how people approach diversity too. Like when someone says, I have been discriminated against, folks get defensive, right? And they're like, oh, you know what? It wasn't me that was discriminated. And certainly I don't think that what you're saying is right. They don't give enough credit to the person who's saying, look, I've experienced discrimination. So what happens is they kind of disregard it or they double down, right? Because heck, I don't even know what's in this black box. And because I don't know what's in the black box, I'm going to say the system is right. I'm not going to ask any more questions. I'm not going to analyze the results, identify the scale of the problem. I'm not going to do anything else. That challenge also happens from a safety perspective as well, right? So if you have a car you have certain cars, your key in your car will tell your auto manufacturer when you need to get an oil change. And I usually get an email that says, Leah, it's time for an oil change. Now, if my key doesn't say, okay, well, you know what? Leah drives kind of fast. And Leah, she has she drives a lot of miles, right? These outliers, me being an outlier, could perhaps impact the the need for me to get more frequent oil changes versus the time that was identified by the system. And then again, we had a whole bunch of folks that were blaming DEI for Boeing's system failures, but they weren't looking at the technology and the fact that Boeing wasn't being as what we'll call proactive in identifying where there could possibly be additional challenges, whether when it came to safety and the equipment, or even when it came to the 737 MAX. So those types of things can impact your brand. They can also result in lawsuits. So when you are doing things manually, right, and you have like one or two individuals that are impacted, they could possibly sue. But technology allows you to scale, right? It allows you to improve efficiency. That's a good thing. But the bad thing is it improves the efficiency of the bias or the discrimination. So it makes it more efficient, which means that instead of one or two people being affected, now you have 1,000 or 2,000 or 1 million or 2 million people being impacted. So the scale is much larger, which is a liability challenge. It's a legal risk for the organization. Um, but another challenge comes in your ability to gain additional skills. Whether you are upskilling, reskilling, or even cross-skilling, um, we know that in the past, DEI is often blamed for job losses. Oh, someone's taking your job, right? But technology, in a lot of respects, does make things more efficient, which in many cases may reduce the need for certain jobs, or even certain roles may become outdated. And organizations are becoming attuned to those individuals who don't take the time to upskill and reskill, especially in critical areas like uh, artificial intelligence and machine learning. So, as we see the world moving to this area, if we are still mystified by technology, we're in the place where we're not as valuable as those who have this information and know what to do with it. So, in this AMBP-L program, we will be in the position to help the organization to identify those outliers, looking at things like time, and the impact over time, not just saying, hey, let's put this system in place and let's leave it alone and let it do what it does, right? We will also be able to look at the training and how the training data um, is impacting the clustering model, the cluster, but also those outliers, right? So as we're talking about the percentage of load, we're looking at both the data that the data scientists input into the system, but we're also looking at where bias could potentially iterate in the system over time. So we want to ensure that we're constantly monitoring the system, and we know what questions to ask regarding transparency, fairness, consistency, as well as develop strategic communications to ensure not that we are placing the blame somewhere else, like saying, hey, it's DEI's fault when we know that it's not, but actually making it so that we can identify problems and communicate them before they become large scale risk, before they become large scale problems that ultimately impact millions or thousands of people. So um, the program is divided into 4 knowledge domains. One is the human side of technology. The second is a correlation between business performance and bias prevention. And not only do we talk about the business case, of course, we do the business case in everything we do, but we also look at the business use case, which is a different concept. We look at forward thinking strategies to improve user experiences and really talk about, uh, do a deeper dive into engagement, ethics, and evaluation. So these are the 4 knowledge domains for which all of the competencies will fall under. And there are a total of 10 competencies that fall under those knowledge domains. And the competencies are the types of bias, the triggers and the stereotypes, the business and how all those things are related together. And specifically, as we're talking about, on a scale, what it looks like, how you can have assumptions that lead to, and where assumptions play a role in AI and ML, especially as we're talking about analyzing the data and making decisions and all those different things. But again, monitoring those processes and really making it so that we're talking about how assumptions can translate into stereotypes, can become biases and lead to discrimination, or even, uh, lead to racism, sexism, homophobia, xenophobia, all sorts of different things, right? And then we look at linguistic bias and language processing and what that actually means and how they're different. Everything from defining linguistic profiling to making it so that we are talking about um, this whole idea of how language can be processed. And then we move into design flaws and filter biases, solving for fairness, and what that actually consists of, especially as we are working towards a more effective way, especially as we're talking about the processes. We'll talk about analyzing discriminatory trends and utilizing diverse teaming models for UAT or user acceptance training. And one of the things that we'll look at here is not only diversity recruiting, but helping the organization to have more allies and accomplices, utilizing resource groups, industry partnerships, doing training, all sorts of different things to help you with that UAT. And then, of course, measuring anti-bias accuracy levels. And this is something that is very important because, again, sometimes when we think about bias, it's an afterthought and it's not something that we think about in the beginning stages, right? Like, okay, as we're designing this software, as we're designing this new system, we're not making it so that we identify the ways that bias could possibly crop up, and we're not really doing all that we can to assess those outliers. We don't have the proper systems in place to install and review feedback um, mechanisms, and we're not really looking at we're not going beyond those outages, but driving deeper into that data, where we're asking questions like, are certain groups predisposed to a system failure, right? And we're not asking questions about false readings or even analyzing those results that ultimately will result in inconsistencies. So at the end of the day, what we want to do is make it so that, again, this tool isn't used as a magic bullet, right? But where you can think differently about preventing and fixing where bias can manifest in a system, or where it can iterate and how it impacts your users, your patients, your students, your customers, all those individuals that you interact with. Um, the course will help you to understand customer and global concerns about diversity, fairness, inclusion, accessibility, accountability, transparency, and bias, and really help you to think about things that you may not necessarily think about at the outset, such as accessibility. That is not normally something that able-bodied people think about. And I always use the example of my son, who is left-handed, and how, as a right-handed person, I am always giving him the pencil or the fork or the toothbrush and putting it in his right hand. And he switches it over to his left hand, which is a reminder to me, oh, yeah, this kid is different. So, but I normally don't think like that on an average everyday basis. And that's how it is when it comes to accessibility as well. We're not thinking about accessibility on an everyday basis, right? Because it is not something that may come natural to us, especially if we're able-bodied today. Now, keep in mind, we are seeing an aging population. So as we're talking about the demographics, which we do dive into the demographics and how this is going to impact your users, not only today, but in the future. But those demographics are ultimately going to play a role in people. Yes, we're temporarily able-bodied. Thank you, Kevin. Yes, we're things are changing. And as things begin to change, how is our technology built to accommodate those changes? Um, the program helps you to initiate team conversations about the impact of biased software and systems on marginalized or diverse communities. It helps you to balance self-regulation with concerns about fairness and privacy. Um, and again, we dive deeper into all these different topics. You'll have opportunities to operate effectively in different global markets, provide more value to customers with advanced insights about your product's bias prevention capabilities. Because people are concerned, and there has been a study that was published on LinkedIn as well as all throughout. It was on CNBC and in a lot of business journals demonstrating how people do not trust technology. And if you're marketing your technology or you're marketing your product and you say that it is AI enabled, you have a greater chance that people will not buy it unless is human led. And we give you examples of what human led marketing is demonstrating the power of AI. So you'll learn how to balance those concerns. But again, the real reason why people don't trust the technology is because they don't trust the people who are behind the decisions. And we talk about what that looks like and how that impacts your organization. Um, and certainly, as we're talking about the lack of trust, what happens in an organization is you spend millions of dollars upgrading your technology and upgrading your capability with these advanced systems, and then find out, okay, we had a lawsuit or we had some kind of system failure that causes us not to be able to use the technology. Think about Boeing and how they have all these advanced technologies and advanced capabilities, but yet now waste in customers as well as so we don't want to invest in technology that is ultimately going to lead us down a path that will lead, that will produce waste, satisfy customers as well as lost sales. And then we want to also eliminate eliminate costs associated with quality issues or product recalls, right? Or downtime. All right, so our process is that you will engage in peer, and I don't know how to make my phone stop. I mean, my computer stop ringing like that. So go figure. Uh, our process is that you will engage in peer group discussions. You'll evaluate case studies and lots of examples. We'll watch short videos in our sessions. We'll utilize quizzes to reinforce the knowledge and learning. We'll provide access to our SEAN learning management system, as well as provide a safe platform for you to ask better questions and to develop solutions. Our course networking learning management system is advanced technology, and it will allow you to not only stay connected to your peers, but it will also provide a trove of resources and information that you can use in your ongoing efforts to prevent bias as well as ensure that you can mitigate the risk associated with bias. Ultimately, it is IDC's goals to make sure that this program can be used to help organizations to do business better, to improve technologies that do awesome and amazing things, right? But there is an opportunity for us to get to better outcomes and make sure that we don't have uh, problems that are going to be harder to fix later on. This program is open to a little bit of everybody, of founders, IT executives, um, tech professionals, people who work in a variety of different capacities in the tech sector, but also we want individuals who are in the buying capacity or risk management capacity to participate in the program, as well as those C-suite, DIA, HR, and other leaders, because the objective is to ensure that we can collectively work together to come up with solutions to addressing the bias that is inherent and make it so that we are asking the right questions. Again, this program is not going to be a magic bullet. What it does is it helps you to ask the right questions and to learn the information that will help you to engage in bias prevention before a problem crops up, and not wait until after we have thousands of people that or hundreds of people that are impacted, right? So we want to learn what to do when bias is found and really be able to take the steps to remove the bias. And again, it is a technical program. Um, you will learn a lot of different things that you don't currently know. And that is whether or not, whatever capacity you work in. Even if you are in DEIA, you're going to learn the technical components of working as a data scientist. If you're a tech professional or data scientist and engineer, you will learn the technical components of the human-centered process, right? The the and we talk about the different design modes and inclusive design, accessible design. We look at human-centered design and dive what that actually means for the work that you're doing. And certainly, all of these things are going to be important. So it is going to challenge you to think a little bit different about the work that you're doing. And you will acquire a new skill set, but that skill set will be valuable no matter what your work is. So, does anyone have any questions or thoughts or comments? Any questions? I'm going to open the floor at this time.